Section 1.3, graphing data, is actually the last section in Chapter 1, and this is kind of summarizing our introduction to physics. We've talked about math and how we use math in physics. We've talked about the scientific process and how do we go about establishing a problem. And the last part of the scientific process is kind of combining math and the scientific process in the regards of you have to show your data, and the best way to show your data is in a graph. So when we talk about graphing, we're going to go through a couple terms and how it works, but then more importantly, I'm going to show you how to graph in Excel. And the reason we do that is I recently, this summer, I went to a 4-day workshop, and as a part of that workshop, I got to do a job shadow in the cities with a major corporation. And we were talking about, some of these corporations were General Mills, Cargill, Best Buy, Boston Scientific, and I actually got to go to Target. So I got to tour Target headquarters in downtown Minneapolis and, visit with the company executives and kind of talk to them about what they want for the 21st century student, which will be you guys, to get a job. And they said one of the things you're lacking is how to do spreadsheets, and it's something so simple as using Excel, but it's a needed skill. So we're going to show you how to do that. So when we talk about graphing, we have two types of variables. We have independent variables and we have dependent variables. Independent variables is a factor that can't be changed or manipulated, which is almost 90% of the time when you graph in here, it's going to be time. I shouldn't say 90%, but most of the time, you can't manipulate time. Right? It's going at a steady pace. You can't change time. Dependent variables are factors that depend on the independent variable. So we could be talking about, if we're graphing velocity, this would be distance. If we're graphing acceleration, that would be velocity. Every factors that depend on the independent variable. So things you can't control, your distance, your velocity, stuff like that. The thing that we can't change, the thing that we control, that's a poor wording, but the factor that can't be changed or manipulated would be time. And anything else that most likely is going to be your dependent variable. Even mass, if you think about mass, when we have a collision with something, our masses are changing. So mass can change. So mass could be a dependent variable as well when we talk about that. So two types of variables, independent and dependent. Right. Graphing basics, and we're going to go through this when we I'm going to walk you through this exact slide when we do the Microsoft Excel spreadsheet. But here's just some very simple. This is the basic of basic graphs. All right. Science, we use line graphs. Rarely are we into bar graphs or pie graphs or anything like that. We use a line graph, especially in physics, because why do we do that? Because we can see the trend line, and we can analyze the trend line, and we can put an equation in the trend line for the most part. You always are going to add a best fit line, which is a straight line that goes through all your data points. The best part about when you're using Excel is you can just right click and boom, you have a trend line. It's not like when you're graphing by hand and you got to try and connect all the dots. The computer does it for you now. Your x-axis is always your independent variable. So your x-axis is your independent. And remember from the last slide, your independent is a factor that doesn't change. So, for example, you're going to have seconds a lot on the independent seconds is the independent variable, which you will have on the x-axis. Y-axis, likewise, is your other variable, which is your dependent variable, as we talked about distance or velocity or anything else. And then you want a proper title. You need to describe your graph. So if we look at, and this is, I always use this line graph because it's always kind of amusing to see what we've done over time. This is U.S. expenditure in education, and on the, remember it's a nice graph. It's labeled on the left-hand side, 2001 constant in dollars and the millions of dollars, and the year. And that kind of shows how we have spent total money in education in the last 20 years. It has doubled. But you can see it's kind of doubled every 20 years. 1960 was there, 1980 there, 2000 there, and 2020 probably way up here. Likewise, when I always do this graph, I joke that teacher salaries have done the opposite. I'm just kidding, but It's a good little joke. So those are the 5 basic things for graphing. I'll kind of show you how to do those when we go through Excel. And the last little bit of graphing information is once you've established a graph, you have to always, not always, but most of the time you're going to have a relationship. And there are 2 types of relationships. You have linear and nonlinear. And linear obviously means line, so it's a straight line relationship. You guys have worked with this in algebra. Y equals mx plus b. That's a very simple graph. M is your slope, b is your y-intercept. Now, if you ever get asked to solve for the slope of something, remember, change in y over change in x. So if this line, this point here was 6.6, and this line here was 3.1, my change in y would be 6 minus 1 over 6 minus 3, which would be the slope of this graph imaginarily would be 5/3. So keep that in mind. Linear relationship, y equals mx plus b. When we talk about nonlinear relationships, right, we are talking about a curved line. And there are a couple options when we talk about nonlinear relationships. And the first one is a quadratic relationship. And on the bottom of the screen, you can see there are 2 graphs. And on the left side is the quadratic relationship. That forms a parabola. And that equation is y is equal to ax squared plus bx plus c. So quadratic relationship, one variable depends on the square of the other. And you can see it forms a nice parabola. While your inverse relationship is on the right side, and that is a hyperbola. And that equation is y is equal to a over x. And then what you have in a hyperbola is you have both values approaching infinity. All right? Both values are approaching infinity if you would go outwards. So as one number gets higher, the other one gets infinitively lower. So for example, on the bottom here, you see the equation is y is equal to 1 over x. If x was 1 million, y would be 1 millionth. So you can kind of see the graph there and how it would plug in. So 3 types of relationships. Linear is a straight line. Then there are 2 types of nonlinear. You have quadratic and inverse. Right? Now, your assignment, we will do this in class, is to graph multiple problems. So if you do this in school, I believe all the computers are updated with the latest version of Excel. Well, not Windows 8, but it's Windows 7. So you'll deal. It's Windows or 2013 Excel. So this is, I think all the computers have this. If not, the 2010 version is very similar. If you're dealing with a 2007, you may have a few changes, but for the most part, it stays the same. So whenever you are graphing in Excel, you're going to have a list of x values and y values. And what works best is if you put your x values in the first column and your y values in the second column. So I am just going to do some numbers here. 0, 1, 2, 3, 4, 5, 6, and 7. And likewise, let's put some numbers in the y column. Right? So I've entered my data. Now, how do I go about doing a graph? Well, you're going to highlight your numbers, just like this. Whoop. Just like that. You're going to go to Insert, Recommended Charts. And on the charts here, you can see they have all sorts of stuff. So we can do a column, we can do a bar, we can do a spider web if we wanted to, a radar chart as they're called. We can do a line, or we can insert a scatter or bubble. And you're always going to insert a scatter or bubble. And if you hit the down arrow, you can see the multiple options of the graphs. And as I scroll through them, you can see kind of how they change. All right, we don't deal with bubbles, we just want scatters. And what I really want you to do is I want you to just do the blank just like that. All right, so we do the blank one. Next is when we were talking about you always kind of want a title for your chart. Well, we can just plug that in real quick and we can go physics example. All right. The next thing, all right, that you're going to want to do is you're going to want to make sure that you have your X units and your Y units labeled. So you're going to go to quick layouts and you're going to see the very possible layouts, and you can just click the first one. And you can see that it has axis title, series 1. Now, one thing I never like is this is a line graph. You can really delete series 1. It's just, you know that all the dots are there. But if you're going to put in titles, it's very important to label your X and Y axis. So I did not label these any, but we could say that this was time. And you always have to do units, so we would do seconds. And we could say as well that this is distance. Maybe we're making a velocity graph. And that was in meters. All right. So we have our title. We have our X and Y axes properly labeled. And really the last thing that you need to do, which is an easy step, is you are going to format these lines. And you're going to add a trend line. Now, how do you add a trend line? Very simple. You're going to, on one of the dots, you're going to right click. It says add trend line. Now, with the new Excel, you're going to have all these options come up. You want the best fitting line. So you could go through, that really doesn't fit. Oh, can't even do that one. All right. So we can't even really do that one. Linear is the best fit. So we're going to stick with linear. Now with linear, and this is the best part, is if I want to know the equation in this line, for example, if I wanted to calculate out at the 9th second, where will I be for distance, I can display the equation on the chart. And the equation's right there. Y is equal to 3x plus 5. So I could figure that out. It's perfect. It works out great. So I have my equation. Now, we also, format trend line, there's a display an R squared value on the chart. And that is going to show you how accurate your line is. Now, my R squared value is 1, which means my line is perfect, which it would be if it was linear. But if I picked, let's go back and pick exponential. You can see how that value changes and my equation changes for my graph. All right, which I don't want. So I'm going to go back, add trend line. I want a linear trend line, and then I will delete the other one. All right, and you can play around with this if you're into making things look really beautiful and all sorts of stuff. You can change the colors of these lines, and I don't really care about that. It's going to print as long as I can see it when you print it. It's not going to ruin my day. So that is kind of graphing 101. It's really simple to do. There you go. And really, this is only like skimming the surface of what Excel can do. When you're really designing a spreadsheet, you're going to put in different functions, which is great to do. But that is how we graph in Excel, and that's how you're going to do your assignment in class tomorrow when we go to the computer lab. If you have any questions, you can get me there.